All right, CNT120, Chapter 3. We are moving on to the section on port numbers. So port numbers, remember, this is a way to identify a process or application that's running on a device. I like to say, think about your computer that's running. You typically have it running and you'll have a browser open with it, a tab doing something in. You'll have your email open. You'll have maybe an audio stream going on or video stream going on. Well, the data coming into your computer, all that data is mixed together as it comes into your, into your network card into your computer. Your computer needs some way to know this chunk of data rolling in. Does it go to the email application or go to my browser? Well, what happens is any application that you're running has an associated port number with, so that gets stamped on that packet in the TCP header. So as it comes in the door of your computer, it can look at that port number and go, oh, that's a piece of email, put it in the email application. Oh, that's a piece of web browser, put it up in the web browser. Hey, this is a piece of this audio stream, put it over in the audio stream application they have running. That is how your computer can sort those out. So any application running has an associated port number with it. So taking a look here, your client talking to a server, your client has a handful of things running, but over on the server there might be multiple things running. So as I go to communicate with that, the server would need to know which thing do you need, and again it's going to look at those port numbers to know what are you trying to ask for. So we also want to mention what a socket is. So a socket would be the combination of the IP of that server with the service that's running on that server. So we would have an IP address of this server, and if we're trying to communicate with the DNS part of it, we would then need that port number to communicate with that service that's running on that server. So those two pieces together are called a socket. So if I were trying to communicate to, the telnet portion of the server, here's the IP address, I put a colon there and that port number behind it to indicate that is the service I want to access. This whole thing is now called a socket. If I were trying to access the SSH portion service running on that server, SSH is port number 22, I would use the IP address followed by :22, that service that's running on that server. And this whole thing right now is called a socket. And that allows us to communicate to a specific service running on a specific device. That's what that allows us to do. Now, my port numbers are ranged from 0 to 65,000, and they're managed by IANA, and they have them broken into 3 distinct types: well-known port numbers, registered port numbers, and then unregistered port numbers, or dynamic port numbers, if you will. I should say dynamic port numbers. So the first well-known ports, 0 to 1,000, are all well-known applications that get used. Things like your browsing, things like your DNS, HTTP, your DHCP 6768, DNS 53, sending mail 25, SSH 22. These are all well-known ports, so those are in that first block of numbers. The registered ports would be all kinds of applications that we would be using. I showed a couple here, like remote desktop, RTP for phone calls, SIP for setting up phone calls, VNC for doing virtual computing on a device. All these have port numbers with them. This also even includes some gaming systems or consoles or applications that you would be running. There would be an associated port number with that. And then there's also dynamic or private ports. A lot of times our browser ends up using these ports up here to represent a certain tab in my browser. 49152 for the first tab, 49153 for the next tab in my browser kind of deal. Here is, these are some tables I kept from, I'm not sure they're in this book now. I think they show them in a different format in our book now. These I kept from a previous book. Here is a whole bunch of well-known TCP and UDP port numbers. I'm going to say familiarity is going to be key. I have some matching questions in your homework quiz. Those would be some of the ones you want to match up. Your FTP, SSHs, your sending mail, DHCP, HTTP. As I move over here, your receiving mail, POP3, and then IMAP4. Down here, here's your network time protocol. Here's secure web, etc. All right. If I wanted to look up any particular one, I can open up the Wikipedia page on TCP and UDP port numbers. It's a great resource for looking up a port number. What is this port number, or what's the associated port number for a certain application that you're dealing with? Well, this section of the book then starts doing an introduction on some applications that you'll run across. So again, these, I'm going to say familiarity is the key. At least recognize what they're talking about. So here's the ones they're mentioning: TFTP, NTP, LDAP, SMB, syslog, SIP, and RTP. Let's go through and just pull out some of the basics on each of these. TFTP, Trivial File Transfer Protocol, uses port 69. That's an application we'll be dealing with. This allows us to send basic text files from something like a switch or a router back to a central location for storage purposes. This is connectionless. It does not guarantee delivery, but it's made for very small basic text files, if you will. We use this for backing up router and switch configurations, and we actually do this in one of our labs in 125, so you understand the process and how to do this. You might console into a router, and when you're done, save this config local, but then also save it here to back up on your TFTP server. That can be done for router switches and other devices in your network. NTP, port number 123, Network Time Protocol. My computers and cell phones and so forth get their time from a time server using NTP. So the computer on the clock on your computer is communicating out to an NTP server that says this is the time. And these NTP servers are very precise and can get you very precise timing. So NTP is the protocol that's going to go out and get that information, bring it back to you, and assign it to your computer. That's what's going. That's the process there. There is a fun video here about a gentleman that works with the network time and network time servers. It's just a couple-minute video talking about kind of the behind the scenes on that, and they jokingly call him the Time Lord for any Doctor Who fans out there. LDAP, lightweight Directory Access Protocol. My goodness, port number 389. This is a protocol being used for accessing network-based directories. So we're talking about directories of things. This would be a protocol that's getting used to access that information. So as we look here, accessing these different directories on something like a Active Directory server. So having access to those or finding those. Server Message Block, SMB, port 445. This was first used in earlier Windows OS for file sharing, and you could actually do a Samba server, SMB Samba server, on a Linux system and move files between Windows, Linux, and even Apple in those days as well, using a Samba server to do that. So SMB, Server Message Block. Syslog uses a series of ports. Syslog is used for generating, storing, processing messages about events on a system. It doesn't alert the user a problem, it just keeps a history of messages issued by the system. So you would need to be checking them to know, is there anything of concern that I need to deal with? And I would have a syslog like so, showing events. Some are just events that things started. Some are events like, hey, we have a duplicate IP address kind of deal. This would be information that you're accessing to find out if there is issues on a device. SIP, Session Initiation Protocol. This gets used for a lot of multimedia things, mainly for voice. This protocol gets used to set up a phone call, and once the phone call is set up, it usually hands it over to another protocol to actually carry the voice data. So you could think of this as the dialing and ringing protocol, and then it hands it over to one that's actually going to carry the payload. So there's your SIP setting it up, inviting a phone to a call, and then once it's set up, boom, it hands it over to RTP. So our next protocol is RTP, Real-Time Transport Protocol, port 5004. This is here to actually carry the voice payload data, if you will. So once SIP sets it up, the other person picks up their phone, if you will. It hands it over and says, RTP, you do the job. And those two typically directly communicate with each other. So once SIP sets it up, RTP kicks in and carries the voice data back and forth between those two phones. Well, In networks, it is handy sometimes to use utilities to look at these protocols and see what's going on. That can be done with something called a protocol analyzer, also called a packet capture tool or packet sniffer. These would be some different names for the same thing. This allows you to see activity in the network as it's occurring, and with that, for our sake, learn, but as a network admin, see if there is issues with data flow. Example, once upon a time, trying to send a data TFTP router to a backup server. It was not working because the server was set up to save the files into a directory that was not secure, so it was erroring out. I used Wireshark to see that it was getting a rejection. And I'm like, oh, okay. I go check the server and adjusted the folder, and boom, and then it saved right in. So it's handy for troubleshooting purposes. Something like Wireshark is an example of that. Really, really useful tool. It's a powerful tool. So I put a little disclaimer here. We use it in our lab room or labs as a learning thing. In IT, you would use it as a troubleshooting thing. But please make sure you don't install this on a computer at your place of work or try to run this at your place of work. It'll look like you're trying to compromise or glean data from the network. So if you download and use this, make sure it's on your own computer, on your own network kind of thing, not on anything work related. Just that's my little disclaimer there because of the power that it's able to do. You can actually glean quite a bit of information. And here will be an example of your protocol analyzer running. All right, when we come back, we'll start talking domain names.